Okay, good morning. Shall we start? Okay, so the first problem we want to check is this one. Okay, this is the problem of Lagrangian interpolation, and we discussed it twice. Okay, and we want to consider this problem first. So this says that the f of x is a polynomial in x, satisfying f of 1 is equal to 2, f of 2 is equal to 7, f of 3 is equal to 1, and f of 4 equals 8. Okay? So if you look at the problem 1 and 2, okay, you notice the little differences. Okay, that is the degree, right? These two things, only the degree are different. Here 3 and here 4. Okay. So, and also other thing is just the f of x is the degree of at most 3 and 4, right? So just we want to find it. Okay. Then so this is a solution, but let me just explain a little bit, okay? So f1 of x, this is f of x, but I just wanted to use f1 of x later here, okay? That's why I wrote it as f1 of x, okay? And since we want to find a polynomial, okay, and the first one is polynomial of degree at most 3. So f of x should have something like, say, ax cubed plus bx squared plus cx plus d. This is the polynomial of degree at most 3. At most 3 means a may be equal to 0. Okay, but this is a general form of polynomial of degree 3. Okay, but polynomial or the solution I've written is a little more complicated. Okay, but just understand that this is the polynomial of degree at most 3. Okay, so you have x minus 2, x minus 3, x minus 4 here, and in the denominator it's a little bit complicated form, but this is a number, right? So this is negative 1, this is negative 2, and this is negative 3, right? So this is very complicated, but this is a number. Okay, and also this 2 is a number. Okay, so the part involving x, okay, in determinant x is only this part. Okay, so this is x minus 2, x minus 3, x minus 4. If you multiply out, or if you expand it, okay, then the highest power of x which you get is x times x times x. So x cubed is the highest term you will get, right? So the degree of this part is equal to 3. Okay. How about this? This looks very similar. So the degree of this part, and if you forgot the definition of the degree, I talked about it several times, so please review the handout. Okay, so the degree of this polynomial is 3. And also degree of this polynomial is 3, and degree of this polynomial is 3. Okay, so altogether, if you add them together, you will have a polynomial of degree at most 3. Okay, because the degree 4 or 5 and x to the 4th power, 5th power do not appear. Okay, but still I want to say that the degree of this polynomial is at most 3, because you have some coefficient, right? So if you add them together, in this particular case, if you add the coefficient of x cubed together, I'm sure you will get non-zero number. Okay, but since the form is very complicated, you cannot tell whether the coefficient of x cubed is 0 or not, right? So I say that this is a polynomial of degree at most 3. Okay, because anyhow the polynomial involving is just x up to x cubed. So this is the polynomial of degree 3. Okay, and this is the solution. And if you look at the theorem, this is written something like, say, 2 times q1 of x plus 7 times q2 of x plus 1 times q3 of x and 8 times q4 of x, and p of x is equal to x minus 1, x minus 2, x minus 3, x minus 4. Okay, and if you look at it, then you will find that a1 is equal to 1 in this case, a2 is equal to 2 in this case, a3 is equal to 3 in this case, and a4 is equal to 4, and the 2, b1 is equal to 2, b2 is equal to 7, b3 is equal to 1, and b4 is equal to 8. Those are the numbers here. Okay, so if you apply that theorem to this situation, you will get solution. Okay, just let's check one value. Okay, so if you plug 1 in to x, okay, f1 of x, if you plug 1 into x, you get 1 minus 2, 1 minus 3, 1 minus 4, and that is exactly same as the denominator sitting here. So that cancels out, and you get 1, but since you have 2 here, so the value of this part, if you plug 1 into x, you will get 2. Okay? What about the rest? If you plug 1 into here, since 1 minus 1 appears, so this is 0. Here, again 1 minus 1 appears, so this is 0. And 1 minus 1 appear here, so you get 0. Okay? So altogether, what you have is what remains is only the first part. Okay? We call it first term. Okay? That is 2. So if 1 of 1 is equal to 2, that satisfies this condition. Okay? Similarly, if you plug 2 in and the 3 in and 4 in, you will have the desired conclusion. So this polynomial satisfies the condition. Okay? Then what about the problem 2? Okay? Problem 2, we want to find a polynomial of degree exactly 4. Okay? Exactly 4. Okay? So this polynomial, the first polynomial, I've written as a solution to number 1, that is of degree at most 3. Okay? We want to have a polynomial of degree exactly 4. Okay? But if you look at the proposition, U4.2, I believe, then the general form of the solution of number 1 is this polynomial plus h of x and p of x. And h of x is a polynomial of degree, say, in that case, n minus. So n minus, say, in this case, 4. Okay. So since that's 4, because there are 4 numbers, a1, a2, a3, a4. Okay, but just forget about it. Okay, so you have something at the bottom. Okay, what is p of x? P of x is the one I've written here. Okay, let's understand what we have here. Okay, so we are just concerned, or we are not interested in only the values at 1, 2, 3, 4, right? We are not considering the values at somewhere else. Okay, so if you plug 1 into p of x, you get 0. If you say plug 2 into this, again you get 0. 3 into this, again you get 0. 4 into this, you get 0. Okay, that means as far as you have this p of x, okay, it doesn't say affect or doesn't have any influence to the values of f of x. Okay, as far as 1, 2, 3, 4 are concerned. right? So even if you add p of x times h of x, okay, here, if you plug 1, 2, 3, 4 into x, it doesn't change the value of the left-hand side. Okay, so the general form you have this type of thing. Okay, and this is the general form that is proved last time. Okay, so the idea to have the polynomial of degree 4 satisfying these conditions is to just add something like this. Okay, but we want to have a polynomial of degree exactly equal to 4, right? And this part, f1 of x part, is of degree at most 3. Okay? So if you just add something like x to the 4th, then that will give you the polynomial of degree 4. Okay? But if you just add x to the 4th power, then that may change the value of f1 of x. So use this p of x. And in this case, I just added this p of x at the end. Okay? So even if you add p of x, if you just plug 1 in, the p of x part gets 0, right? P of x part, even if you say plug 2, 3, 4 in, you get 0. So it doesn't change the value of f of x. So this is the solution you should have. Okay? But as you can see, well, as you may see, okay, there are many other solutions. Do you have some idea? For example, if you say 2, okay, this is all right, right? Because if you plug 1 in, 2 in, 3 in, 4 in, this part is equal to 0. So even if you have 2, then you get again 0, right? So that means here you can have any constant, okay? So say c is fine. C, if the c is a constant, okay, this is fine, okay? And so you can have any number here, okay? The important thing is this part, the last part, is of degree exactly equal to 4. Okay? What is the coefficient of x to the 4th power? Okay? At least the previous part, f1 of x part, that is of degree at most 3. So x to the 4th power doesn't appear, right? So x to the 4th power, if it exists, then that appears from here. But if you multiply out, you can easily see that x to the 4th power appears, and the coefficient is this little number you added, right? So in this case, we can claim that if you want to add constant c, then that is, if that is, as far as that is not 0, okay, this is the polynomial of degree exactly equal to 4, okay, right? Then what if the problem is asking you to write a polynomial of degree exactly 7? What should we do? Any idea?
You can probably multiply x cubed to 4 dx part.
That's right. This part, okay, let me just use different color. Oops. Okay. Just multiply this part. That is, if we choose appropriate h of x, okay, then we can find any polynomial of degree, any degree. Okay. In this case, I said that the degree 7 case. Okay. If you want to have degree 7, okay, we want to have something non-zero constant times x to the 7th power somewhere, right? And the not higher terms. So here we want to have x to the 7th power. Okay, this part altogether you have x to the 4th power, right? In order to have x to the 7th power, okay, we wanna multiply x to the cube, right? it doesn't have to be just x cubed. So you can just say something times x cubed plus something times x squared and so on. Okay, but the simplest case may be just x cubed. Okay, that means if you just multiply x cubed here, okay, x cubed part, since it's a product, okay, if you plug 1 and 2 and 3 and 4 in, this part may change, but it doesn't affect anything, right? Because the former part here, if you plug 1, 2, 3, 4, you get 0, right? So by this, you can get a polynomial of degree exactly equal to 7. Okay? So in that way, you can find infinitely many solutions. Okay? But in the former case, degree 3 case, degree at most 3, there is exactly one solution. Okay? In this case, there is no polynomial of degree at most 2. Okay? So the solution to this problem is either 0 or exactly 1 or exactly infinite. Not exactly, but infinitely many. Okay? So that is a kind of phenomena we have already experienced, right? In the system of linear equations. Okay? So this is somewhat very similar to the system of linear equations. Okay? And in this case, if we restrict the degree to be at most 4, okay, let's think about why we had at most 4. Okay? Because we are assigning values of 4 places, 4 values. Okay? Then in that case, the degree is at most 3. Okay? There is a polynomial of degree at most 3. So if you are assigning values at n points, okay, then you have a polynomial of degree n minus 1. Okay, so please look at the say linear, say line or the quadratic form or quadratic polynomial and other things. So then you can just check the degree. Okay, so that is it. Okay, so as I explained in the beginning, that there is another way to solve this problem, that is to use the system of linear equations. Okay? But that is a little bit more complicated. That involves lots of calculation. That's why this Lagrangian interpretation is very wise or clever. Okay? So that is it. Let me go back to the problem. Okay? So on Wednesday, we are going to have a quiz for, okay? So today we are going to discuss the synthetic division. But before that, I just want to introduce one formula, okay? That is also in the handout, okay? That is a to the nth power minus b to the nth power equals this, okay? Again, you have some, say, summation, okay, sigma mark, okay? But as I told you that this, you may find this sigma sign somewhere in the future, so I introduce it, but throughout this course, okay? You don't need to understand this sigma mark. But I will explain, because this is a very important symbol we use in mathematics, okay? So firstly, a to the nth power minus b to the nth power can be written in this way. A minus b times the next term and next factor starts from a to the n minus first power, okay, plus a to the n minus second power, so the power decreases by 1, and times b. So if you consider that this is of degree 1 in b, so altogether you have n minus 1, and up to b to the n minus 1, okay? Then you have this, okay? And instead of writing in this form, okay, or in order to avoid dot, 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 okay? Dot, dot, dot is sometimes ambiguous, okay? So we, in mathematics, we often use this sigma mark, okay? Sigma is a Greek letter of S, okay? And this means sum, okay? The S coming from the sign, the sum, okay? So this means index is I is equal to 0 to n minus 1. I appears here, right? So this means summation is the sum of this quantity as you plug 0 to n minus 1 into I. Okay? If you plug 0 in, you get a to the n minus 1, b to the 1, and b to the 0. So that you will get this part. Okay? If you plug I is equal to 1, you get n minus 1 minus 1, so a to the n minus 2, and then b to the 1, and you get this. Okay? And you sum them together. Sum it up. So you have this part, and this sigma part represents the sum of the second factor. Okay? Sum in the second factor. So if n is equal to 2, then plug 2n, 2n, so you get h squared minus b squared. Then n is equal to 2, so this part a to the first power, that is a. And then down to b is equal to 1, and you don't have in the middle part, because if n is equal to, say, I is equal to 1, you get n is equal to 2, so a 2 minus 2 is 0, right, b. So that part is just exactly equal to the last term. So a squared minus b squared becomes this. Okay? And a cubed minus b cubed, you have this. And x to the fifth minus 1, okay? Then just this is a is equal to x, and the b is equal to 1, and n is equal to 5, because 1 to the fifth power is equal to 1. Okay? Then if you plug into this, okay, replacing a by x and b by 1, then you have this form. Okay? And you can check it very easily. Okay, just expand them out, then you get this, right? And for the general form, okay, you just multiply out, but this is very long. So first multiply a to the following part, factor, then you get a to the nth power, then a to the n minus 1 times b, and then a times n, b to the n minus 1. Okay? Then you have to multiply minus b to the second factor. So minus, if you multiply minus b, you get minus a to the n minus 1 times b, and so on. Okay? But the important part is the second term of the first chunk, and the first term of the second chunk is exactly equal. Okay? So these two cancels out up to this part, and minus b to the nth power remains. So you have this formula. Okay? So right now in this unit, we do not use this one very often, but in the following unit, okay, we are going to use it. So that's why I introduced it. Okay? So let's try some of them. Okay, so the first one we have already done. Okay, so this is a square. This is a minus 1, a minus b, a plus b. This is exactly equal to this. So this is equal to a squared minus b squared. This is the case n is equal to 2. Okay, let me use red. Okay. Then in this case, this is n is equal to 3 case. So you have a to the cubed minus b to the cube. Okay, this is just easy, I believe. Okay, this is x to the fifth power. Okay, the power rule is very important. We are going to use it very often. That's why I want you to just check your understanding. This is n plus m. Okay. Because the x to the nth power is there are n x's, okay, the product of n x's, and x to the mth power, that is m x's, right? So altogether you have n plus m x's. So you have x to the fifth power. And in this case, considering thinking that x is x to the first power, you have x to the 11th power. Okay? But the backwards is a little bit difficult. You have to know the formula. Okay? But this one, you will get this as a solution. Okay? And the x cubed minus 1, you can get that. But this type of thing is a little bit difficult. Okay? Because the y to the y cubed plus 8, okay, it doesn't look like an minus bn, okay, because this plus is replaced by minus, okay. But if you consider this as y cubed minus 2 cubed, then this is minus 2 cubed becomes minus 8, and minus 8 becomes plus 8. That's why you can apply the formula to get, in this case, y minus 2, okay, and then y squared plus, say, y times minus 2 plus minus 2 to the second power. Okay. Okay, I will give you 1 minute. So please try number 3, and if you have time, then try number 4 as well. I think that is included in the somewhere, exercise somewhere. Exercise 4.2. So the formula you have is a minus b, a n minus 1, a n minus 2b, a n minus 3b squared, a b n minus 1 plus b n minus 1. Okay? Right? Okay, please check the solution later. Okay, it's in the slide. Okay, so now I'm going to introduce the synthetic division. That is in Japanese called kumitate joho. Okay, and very convenient. And in the general case, if you want to divide a polynomial f of x by g of x, okay, then the best way I would recommend is a so-called long division, okay. In Japanese, I think it's called hissan, okay. But this one is more convenient if you want to divide that polynomial by x minus a type, degree 1 polynomial. And we are going to use it later, so I want to introduce this one. Okay. So for some of you, it's just a review. Okay, but I want to introduce it. And if you believe that you need practice, okay, that is also explained in the Khan Academy and also e-college. Okay, in e-college there are many exercises. Okay, so please try. Okay, so this is the method to calculate q of x and r of x, constant r, if you want to divide f of x by x minus a. Okay, x minus a is a polynomial of degree 1. Okay, you can find this quotient q of x, and you can have a remainder which is a constant. Okay, so you can write a polynomial in this way. Okay, so the polynomial method we are going to introduce is a way to find out q of x and r if f of x and a are given. Okay, but this is also a way you can apply to find the value of f at a. Okay? If a polynomial is given, okay, the value at a is very easy. Okay, just plug a into x. Okay, then you can find the value of f of x at a. Okay, but if in some case, okay, if you have a very high power, like x to the 7th power, x to the 8th power, okay, then it's not easy to calculate the power of a number. Okay, and this method, the synthetic division, sometimes very useful, even to find the value at a. Okay, why is it? Okay, because you can write f of x in this way, and if you plug a into x, then this part disappears, right? Because a minus a becomes 0. Okay, no matter what q of x you have, you get r for f of a. Okay, so this r part is nothing but f of a. Okay, so in just some cases, okay, I don't want to say always. Okay, some cases, just in order to find the value of f at a, this method is faithful and very useful. Okay, so let me just explain why it works. Okay, in order to find q of x and r, starting from f of x and a, okay, this r is a constant, so f of x is of degree, say, n. Okay, then this is just a constant, so q of x minus x of a is of degree n, same as the degree of f of x. Okay, and the degree of x minus a is equal to 1, right? So that using the degree formula, the degree of q of x is n minus 1. Okay, knowing that, just write q of x to be in this form, because q of x is known to be of degree at most n minus 1, right? Then we want to find out bn minus 1, bn minus 2 up to b0. Okay, but since f of x minus r is equal to q of x times x minus a, so you just write both of them. Okay, so f of x minus r, just exactly same as f of x, with a little change at the end, constant term. Constant term becomes c0 minus r, because we subtracted r from f of x, right? Then what about q of x times x minus a? q of x is this part, bn minus 1, x minus xn to a minus 1 down to b0. And if you multiply x minus a, first multiply x part, you get bn minus 1 x to the nth power, right? Because you want to multiply x. Okay. What about x to the n minus first power? Then if you multiply this with x, you get bn minus 1 x to the n minus first power. But n to the x to the n minus first power also appears if you multiply the first term with a. That is minus bn minus 1a. Okay? And in that way you can find this. Okay? So the idea is to compare the coefficients of f of x minus r and q of x times x minus a. So Cn is equal to Bn minus 1, Cn minus 1 is equal to this one, and so on. Okay? The important thing is f of x is given. So that means Cn are given, Ci's are given, and we want to find the Bi's. Okay? So I know that I'm very fast, but in that way you can find these equations. Okay? But since, as I told you, we want to find Bi's instead of Ci's. Ci's are given. Okay? So if we read or solve these equations, you get Bn minus 1 is equal to Cn, right? And the Bn minus 2, okay, is equal to Cn minus 1 plus Bn minus 1a, right? but we wanted to find, say, bi's, okay? Then we also have bi here, right? But fortunately, that is already found in the previous equation, okay? So assuming that bn minus 1 is known, you can just plug a bn minus 1 in here, then you can find bn minus 2 and so on, okay? So in order to do it, we write it in this way, okay? So the left hand side you write a, okay? In some textbook, this a is written on the farther right, okay? So this is just another way, but just exactly the same method, okay? On the left hand side, I write a. So important thing is if you want to divide a polynomial by x minus a, okay? Instead of writing minus a, we write a here, okay? If you want to divide it by x minus a, okay? Instead of writing minus a, we just write a here, okay? And cn minus 1, these are the coefficients of f of x, okay? And then bring this cn down here, and then add time this multiply by a, and that is written here, and add them together, you get this quantity, and that is nothing but bn minus 2, and then that way you can find bi's, okay? So please look at this slides later, okay? All right, and I don't want to take so much time here. And in this part, I want you to be able to calculate by this synthetic method. Okay, let's practice. Okay. Oops. Okay, so the problem is like this. Which color do you like? Let me just use black. Okay, maybe different red. Okay, so since I'm a colorblind, it doesn't matter to me at all. But this is a polynomial you have, and you want to divide this f of x by x minus 2. Okay, so we want to write it as q of x and x minus 2 plus r. Okay, we want to consider this type of thing. Okay, so you have some polynomial and x minus 2 and plus r, and this r was known to be equal to f of 2. Okay, in this case, okay, so first write 2 on the left corner. Okay, and then pick the coefficients of f of x listed in the first row. That is 1, minus 2, minus 5, and 6. Right? I just copied the coefficients of f of x. Okay? Then keeping one line blank and draw a line here. Okay? And then first bring this first one down here. Okay? Then multiply with this 2. You write 1 times 2. So this is this one times 2. Okay? And then here you have this plus this. So add them together, you get 0. Okay? Again, write the one, just this quantity 0 times 2. 2 is coming from this. Okay? 2 times 2. So in this case, you get 0, right? 0 times 2. And then you add them together, you get minus 5. Okay? Then, one more step. Okay, so you multiply 2 here. So you get minus 4, minus 10, okay? Because minus 5 times 2 becomes minus 10, okay? Then add them together, you get minus 4, okay? Then we write this fork at the end, okay? What does it mean, okay? Then this 1 minus 0 minus x, this is, say, b0, this is b1, this is b2. What does it mean? That is b2x squared plus b1x plus b0. Okay? And this one is equal to r. Okay? So the formula you get is f of x, that is x cubed minus 2x squared minus 5x minus 6, plus 6, sorry. That is equal to, this is the coefficient of x squared, so x squared minus 5 and x minus 2 plus minus 4. Okay? This is how you're supposed to get. Well, I will repeat the procedure later, okay? So, but anyhow, you will get this one. And so from this, as I mentioned here, you can also tell that f of 2 is equal to minus 4. Okay? If you plug 2 into this, let's check, okay? F of 2 is equal to 2 cubed minus 2 times 2 squared minus 5 times 2 plus 6. But this is 8 and 8 cancels out. You get minus 10 and then plus 6, so you get minus 4. Right? So it's correct. Okay. But anyhow, the important part is not just the remainder, but the quotient part can be written in this way. Okay. So the first one we just bring it down. Okay. Then the multiply by this number, okay, and then add these two numbers and write it here. Okay. So this part is just add. Okay, just multiply this number and then add, and then the last part becomes the remainder. Okay, so you have this. Okay, then I'm doing something else down below. Okay. What am I doing? I don't know whether I have that slides here. I'm afraid I don't have it. Okay, so let me see. Okay, you have this part we have already done. Okay, then next again I wrote 2 here. Okay, and then bring this one down and then add it by this number 2 and then add them together, you get 2 and again multiply by 2 and add them together, and I wrote minus 1 here. That means I'm dividing x squared minus 5 by x minus 2. Then the quotient is x plus 2 and the remainder is negative 1. Okay, so I get quotient to be equal to x plus 2 starting from x squared minus 5. Okay, and the remainder is you get negative 1. Okay, and again I divided x plus 2 by x minus 1. Okay, then x plus 2 by x minus 2 is something odd, but the quotient is 1 and the remainder is 4. Okay, if you add them together, you get the left-hand side, right? So what am I doing? Okay, So firstly, you found this quotient x squared minus 5, right? And also I found the say x squared minus 5 to be equal to this. That means you can plug this one into here, right? But x plus 2 is also equal to this. Then x minus 2 plus 4 also can be plugged in here. Then everything is plugged in, you get this. Okay, please compare with the previous one. Okay, then you get this. Okay, then it's a little complicated, so from here to here it may be difficult to see, but say minus 4, I kept it here, and then x minus 2 minus 1, so you get x minus 2 here, and the next part is x minus 2 squared here, so if you multiply x minus 2 3 times, you get x minus 2 to the cubed, plus 4 times x minus 2 squared minus x minus 2 minus 4. What am I doing? Okay. In this way, if you continue the process of synthetic division, you can write a polynomial in x as a polynomial in x minus 2. Okay? Please look at the second line. That is x minus 2 cubed, and then x minus 2 squared, x minus 2 to the first power, and constant term, right? So if you replace x minus 2 by y, okay, then you get x cubed plus 4x squared minus y minus 4. Okay? So in that way, you can write a polynomial in x, that means the variable is x, okay, as a polynomial in y is equal to x minus 2. Okay? And we can write it in this way. Okay? Why we do it? Okay? Why do we do it? That is to find the approximation. Okay? For example, if we want to find the value of f of x near 2, okay? If you plug x is equal to 2 in, then we know clearly that you will get the value negative 4, right? Because if you plug 0 into the original polynomial, you get the value at 0. That is very easy, right? Similarly, if you change into this form, if you plug 2 into y, then you into x, sorry, okay? Then you get the value at x is equal to 2. Okay? What is the value near y is equal to 2? X is equal to 2. Okay? Suppose x is equal to 2.01. Okay? 2.01, then x minus 2 cubed, okay, is equal to 0.01 cubed. So that is how many zeros? 1, 2, 3, 4, 5. 1, right? And if you want to just take a square, then you get at least many zeros, okay? All right? So that means that's a very small number, right? So, and you have a polynomial in y that is x minus 2, okay? So we can say that hence near 2, the value of f of x is very close to minus 4, or we can also say that minus 4 minus x minus 2, that is over there. Okay? And if you want to get more, say, precise or close approximation, then this up to the second power gives a better estimate. Okay? And the third cubed of 0.01 is this one. Okay, so if you are talking about 1, 2, 3, 4, 5, 6, 5 digits or so, okay, then near 2, that up to the third, say third power, the second power, that is enough. Okay, so nowadays I think you don't have a calculator, but that is installed in your smartphone or something. Okay, in a calculator, or let's say calculator of the smartphone, okay, if you want to find the value of some function, okay, then in the calculator always doing this, okay, calculator can do only the addition and multiplication, okay. So what they do is just find the approximate value, okay. So I think some of the advanced calculator have sine or logs or e to exponential function and other things, okay. But they are not doing finding the exact value. They are using this to find the approximate value, okay. Because the calculator has most of the time you have say only 8 digits or up to 10 digits, right? So if you can find the value in that much accuracy, then that is enough, okay? And the polynomial is very nice because the value of the polynomial can be found only by adding and multiplying, right? So that is very easy to make program. So in that way, the calculator and other things are finding value. So they are doing some approximation, okay? And in this case, the important thing is that instead of finding the value near 0, okay, if you have, for example, look at y, okay, if you plug 0 into y, you can get the value -4 very easily, right? But using the synthetic division, you can also find the value near 0, or if y is assumed to be x minus 2, then near 2. Okay? So you can find the value near at any points using this synthetic division. Okay? So that's the value of this method. Okay, and just let me add one more thing. That is an minus bn. We have done this, but this can be also found by the synthetic division. Okay, because you can write it in this way: x to the nth power minus b to the nth power. Okay, that means we can understand that this polynomial is, say, divided by x minus b, and we want to find the quotient part. Okay, in order to do it by the synthetic division, we write b here, and then we write the coefficients of x to the nth power minus b to the n. That is 1, 0, 0, 0, 0, 0, 0, and then minus b to the nth power, right? Then by the synthetic division, 1 comes down and multiply b. You get you add them with add it with 0, you get b. Again multiply b, add with 0, you get b squared, and then up to b to the n minus first power, you get bn minus 1, and then multiply by b, you get b to the n, but if you add them together, you get 0. So in this case, remainder is 0, and these are the numbers appearing in the coefficients. Okay, so the first formula I introduced, okay, you can also get it by multiplying out or the expanded, okay, but you can also find it by the synthetic division. Okay, all right, let's think about the next exercise. Okay, I will give you 1 minute. Okay, please think about it. It's a little bit complicated, but I have already shown it before, so some of you might have already considered. Okay, this is a little different from the, say, straightforward problem. Okay, and here we want to find a polynomial of degree 3 satisfying f of 1 is equal to 33, f of 2 is equal to 27, and so on. Okay? And the first problem said that find the polynomial of g of x of degree 2 such that f of x is equal to x minus 4 times g of x. Okay? Why we can find such things? Okay? But if you look at this part, the value of f at 4 is equal to 0. Right? That means f of x can be, if you divide f of x by, say, x minus 4, you get g of x times x minus 4 plus r. Okay? And r was equal to f of 4. Okay? But in this case, f of 4 is equal to 0. So f of x can be written as g of x, x minus 4. Right? And it said that the f of x is a polynomial of degree 3. So this is degree 3. And this is the product of two polynomials. And so this is equal to degree of g of x plus degree of x minus 4 by the degree formula. But the latter part is equal to 1 because the x to the first power appears. Okay? So this is 1. So from this you get that the degree of f of x, g of x to be equal to 3 minus 1. So this is 2. Okay? So if you write it in this way, we can tell that degree of g of x is equal to 2. So the problem said that find the polynomial g of x of degree 2 such that f of x is equal to x minus 4 times g of x. Right? Then what can we get? But this has other information. Okay, that is f of 1, just consider f of 1. This is equal to 33. Right? But that is, since we know that it's of g of x times x minus 4, so g of, f1, so this is 1. Okay. G of 1 times 1 minus 4, this is minus 3 times g of 1. Right? So, if you look at the left-hand side and right-hand side, you get g of x is equal to minus 11. Right? Because it's 33 divided by minus 3, you get minus 11. Okay? Yeah, that's right. Sorry, x1, g1. Then what is g of 2? G of 2 is 2 minus 4, and this is equal to f of 2. And f of 2 is equal to 27. And this is minus 2 times g2. So this is equal to g2 is equal to minus 27 over 2. Okay. Then what about f of 3? F of 3 is 14. So you get 14 is equal to f of 3. And this is g of 3 times 3 minus 4. So this is minus fg of 3. So g of 3 is equal to minus 14. Okay? Right? Right? So you know the values at values of g at 1, 2, and 3. So you can use Lagrangian interpolation. Right? Okay, the next one, I'm afraid I don't have enough time, but for this problem, since you know the value, f of 1 is equal to 33, okay? And this is a continuation of the previous problem. But if you plug 1 in, okay, this you get 1 minus 2, 1 minus 3, 1 minus 4. But the rest, you get 0, right? Because every term has x minus 1 as a factor. So you get 0. So you get 1 minus 2, 1 minus 3, 1 minus 4 is equal to 33. So from that you can get B1, right? And you can also plug a 2 into x, then you can find B2, and 3 into x, you get B3 and so on. Okay, please check it. Okay. Since we studied synthetic division, let's try this. Okay. Hmm. これかな？あれ？これかな？あれ？違うかな？これかな？ Okay. We want to find the polynomial p of x and the number r satisfying this. Okay. This is the typical problem of the synthetic division. Okay. So this is the polynomial, right? And we want to divide by x minus 2. So we write 2 on the left upper corner and then copy the coefficient 2, minus 3, and 1 here, and 1 here. And then write the line. Here I will give you 1 minute. Okay, let me do it. Okay, so first bring this 2 down, then multiply by 2 and write it here, and then add them together, you get 1, and multiply by 2, you get 2, and add them together, you get 3, again multiply by 2, you get 6, and add them together, you get 7, right? So what you have is, say, h of x is equal to 2x squared plus x plus 3 times x minus 2 plus 7. Okay, right? Okay, please check out this solution. Okay, then the next one. Okay, please consider this problem. Okay, let me try the first one first. 2 minus 3, 1, 1. 2. Okay, you have this much. Okay, then again we continue this process. 2 here, then bring this 2 down, and multiply by 2, add them together, and multiply by 2, add them together, you get 9. Okay? And again, you continue this process. Bring this 2 down and multiply by 2, and add them together, you get 7. Okay? Next, you don't have to do it, but you can also write it in this way. Okay? You just stop by one layer. Yeah. Then, this is equal to A0, and this one becomes A1, and this one becomes A2, and this one becomes A3, or A3 can be this. Okay? Right? And I'm afraid I ran out of time. So I don't think I can explain exponential and logarithmic function in 2 minutes, okay? And anyhow, we are going to use this exponential and logarithmic function in the next unit, okay? But we will not use, say, include it in a quiz for, okay? But let me just take 2 minutes and then explain it, okay? So we want to find that we want to define exponential function and logarithmic function, okay? Exponential function we have already done if the, say, this power part is an integer or a positive integer. A to the nth power, that is the product of n a's, right? This part is easy, okay? And we can also define the negative power as well, a to the minus 2. That is just a over, say, 1 over a to the nth power. But otherwise, it's a little bit difficult, okay? So let me just say, today I don't have enough time, but say, okay, let me just explain this a to the 1 over nth power, okay? That is also written as nth root of a, okay? That is the positive real number, okay? The definition of this one is positive real number such that if you take the nth power of it, you get a, okay? So, if x is equal to 0, x to the nth power is 0, okay? But x to the nth power is equal to a, and you can always find the nth root of a if a is non-negative, okay? And that is uniquely determined because x to the nth power is equal to a, and y to the nth power is also a, okay? Then if both of them are equal, then x to the nth power minus y to the nth power, this is equal to 0, right? But this one looks very similar to the formula we have studied, right? And if you, say, write it in this way, then the left-hand side, this part, x minus a, and the right-hand side you have this. But you can tell that this part is always positive, okay? Then, say x and y are non-negative real numbers. So this is the non-negative positive part if x and y are not equal to 0, okay? So if this is positive, then the only possibility you have is x minus 1, okay? So the number which you get the same nth power, okay, is uniquely determined. From that, you can define a to the 1 over nth power, okay? So anyhow, this is a very important exponential law or power rule, okay? And we are going to use it in the next unit, okay? And today I couldn't explain the logarithms. I will just touch a little bit on Wednesday, and then review some of the problems, okay? In this handout, we have several exercises, Okay, so please try. And I will explain it on Wednesday, and then we'll have a quiz. Okay, but as I mentioned to you, exponential function and logarithmic functions are not included in the quiz. Okay, let's stop here.